Hello viewers, welcome to my channel. Second matter, the solution to your math problems. We are still on bearings, and then today we are going to look at bearing problems, some word problems relating to bearings. So this is our first question. I read: the bearing of x from y is 70 degrees, and the bearing of z from y is 160 degrees, where x, y, and z are 3 points in the plane. If y is equidistant from x and z, find the bearing of z from x. So now, even before we start solving, 3 key informations have been given here. 3 key informations have been given here. So let's identify them. 1, we've been given the bearing of x from y as 70 degrees. Again, we have also been given the bearing of z from y as 160 degrees. And then finally, we are told that y is equidistant from x and z, meaning that the distance from x to y is the same as the distance from z to y. So these are the 3 key information given in the question. So first of all, let's measure the 70 degrees bearing. If you remember, so now between x and y, where are we to measure the 70 degrees? So we said that in bearings, where we hear this word here, from, that is where we measure our bearings. So it means that between x and y, we have to measure 70 degrees from point y. So let's do that. So this is y. That is where we have to measure the 70 degrees. So again, this is a 3-figure bearing. We said that for 3-figure bearing, angles are read from the geographical north in the clockwise direction. So starting from the geographical north, moving in the clockwise direction, we have to measure 70 degrees. So meaning that the angle here measures 70 degrees. Now, what point should be here? So the bearing of x from y. So this point here will be x. So let's do that. So this point here is x. This point here is x. Now, again, we're also given another bearing. That is the bearing of z from y. Z from y is 160 degrees. So meaning that between z and y, we are also to measure 160 degrees from y. So from y again, we have to measure 160 degrees. So now from the same y, how do we measure 160 degrees? So starting from the geographical north, moving in the clockwise direction. So from the north to the east, the whole angle then measures 90 degrees. And then from north to south, that will be 180 degrees. But we are looking for 160 degrees, meaning that 160 degrees will be in this quadrant. So from 90 degrees plus what angle will give us 60 degrees? So 90 degrees plus what angle will give us 160 degrees? So let's do simple calculation. So you could see that 90 degrees plus 70 degrees will give us 160 degrees. So it means that also from this quadrant, we have to measure 70 degrees. But don't forget that we were told that y, this point here, is equidistant from x and z. So meaning that the distance between x and y is the same as the distance between y and z. So in drawing of this bearing, you must also consider the distance. Although it's not drawn to scale, but the distance we use in drawing this line should also be used to draw the line that connects Y and then Z. So we have to measure 70 degrees from this quadrant, taking into consideration the equidistance. So here is 70 degrees. So now in my case, I used 30 centimeters for the length of this line. And again, I also used the same length, 30 centimeters for the distance between Y and Z. So now this point here will be Z. This point here so here is Z. Here is Z. Here is Z. Here is Z. So now, what shape are we getting? You see that we are getting something like a triangle. But how do we get a triangle out of this shape? So it means that we have to join this line. Have to join this line. Again, we were told that Y here is equidistant from X and Z. So from the diagram, what shows that Y is equidistant from X and Z? So we have to indicate these signs on the line, meaning that the length from Y to X is the same as the distance from Y to Z. So that is what we have done. And also take note, since this is core maths, most of the triangles will be a right angle triangle. So a right angle triangle here means that one of the interior angles will measure 90 degrees. So let's do that and see. So which of the interior angles will measure 90 degrees? Clearly, the whole of this quadrant here measures 90 degrees. Now one part is measuring 70 degrees, so meaning that this side here will measure 20 degrees. So what is the total measure of this angle inside the right angle triangle? So clearly, you can see that this angle here measures 90 degrees. Now, but what is the main question? We have to find the bearing of Z from X. The bearing of Z from X. So from X, meaning that is where we have to measure the bearing. So from X, we have to measure the bearing until we get to Z. So we are looking at this angle here. From here until we get to this point. Now we know the angle in this quadrant to be 90 degrees. And there another angle here, 90 degrees. But there is an angle here. We don't know the angle. So let me represent an unknown angle here as theta. So there is theta here. So for the bearing of Z from X, that would be 90 degrees plus 90 degrees plus this theta. That should give us the bearing. But how do we get this theta? How do we get this theta? Now let's look at something. We have our right angle triangle here. So we have our right angle triangle here. So let me draw it this way. Now we know that the angle here measures 90 degrees. And then this length here is equal to this length. Here is Y, here is X, here is Z. what angle should be here? So clearly you could see that because this is an isosceles triangle, I'm representing the angle here as K. So if this angle here measures K, then this angle here must also measure K because it is an isosceles triangle. So now let's calculate for K. So now we know that the angle K here plus this angle K here plus this 90 degrees must be equal to 180 degrees because the sum of the interior angles of a triangle is 180 degrees. So we have 2K plus 90 is equal to 180. So 2K is equal to 180 minus 90. And then 2K is equal to 90. We divide both sides by 2. K is 45 degrees. So it means that each of the interior angles here measures 45 degrees. So let's do that. So the whole of this angle here measures 45 degrees. Then the whole of this angle here also measures 45 degrees. So now how do we get this angle? Now, from angle properties of parallel lines, what is the relationship between this angle and this angle? So, what is the relationship? So, these two angles are alternating. They are alternating because they are formed from the alphabet Z. And what is the relationship between alternating angles? They are equal. So, if this angle here measures 20 degrees, then this angle here must also measure 20 degrees. So if here measures 20 degrees, then this angle here must also measure 20 degrees. So now we can calculate for theta. We can now calculate for theta. Let's focus on this quadrant here. What is the total measure of this quadrant? Now we know that the total measure of an angle in the quadrant is 90 degrees. So meaning that this 20 degrees here plus this 45 degrees plus the theta must be equal to 90. 20 plus 45, that should give us 65 plus theta is equal to 90. So theta is equal to 90 minus 65. So we are getting theta to be 25 degrees. Now that we know the value of theta, we should be able to calculate the bearing of Z from X. So how do we do that? How do we measure the bearing of Z from X? So from X, meaning that we have to start measuring from the geographical north, from the point X in the clockwise direction until we get to this line. So starting from the geographical north, we are moving until we get to this angle. So what is the measure of this angle here? From north to east, that is 90 degrees. And then from east to south, another 90 degrees. Plus this small angle here, which is theta, that gave us 25 degrees. So what is the total measure of the bearing? So 90 plus 90 plus 25. 205 degrees. So that is the bearing of Z from X. I hope you enjoyed this episode. Thanks for watching.